Okay, this is the notes to earthquakes and Earth's interior structure. So what are earthquakes? Earthquakes are sudden and violent shaking of the ground. It's a result of movements within the Earth's crust, and it's usually at plate boundaries. Now remember, the movements of the Earth's crust is based on the convection currents in the mantle. So if we're looking at a house or a building, starts shaking. It can be a wavy feeling or a shaking feeling. It just depends on where the boundaries are, what's shifting, and if you felt earthquakes, they have a different feel. Why do earthquakes occur? Earthquakes are usually caused when the rock underground, like under the crust, suddenly breaks along a mantle, along a plate boundary. The two plates are rubbing against each other, so it's causing friction. So it can be a reverse fault, normal fault, or it could be a strike-slip fault. And most of earthquakes take place in convergent plates, which are the subduction zone boundaries. This is when a thinner ocean crust converges on or collide with the continental crust, and these are thicker, so usually the ocean crust goes down, gets submerged or pushed down. And so these orange circles are where there's shallow earthquakes, not as much friction, much more friction down here with deeper earthquakes, higher magnitude. So about 80% of all the earthquakes occur in the Pacific Ocean belt, which is called the Ring of Fire right here. And if you remember from the plate tectonic lessons, it's where the Hawaiian Islands formed, and we lived near the Ring of Fire in the San Andreas Fault. So we feel earthquakes. And most of these result from convergent plates. So this is where the ocean plate meets the continental plates. What is the focus and epicenter of the earthquake? The point within the earth where the fault begins or rubs against is down here in the lithosphere. It's called the focus or the hypocenter. Then right above this on the surface is called the epicenter. How are earthquakes measured? They're usually measured by magnitude and intensity. Alright, I'm back. My son needed me something. So, how are earthquakes measured? So, magnitude and intensity. So, per earthquake, it's related to the energy release. And there's different scales: Mercalli, Richter, moment. And usually the Richter scale is what we hear in the news. It was like a 5.5 Richter scale, you know. And this would kind of give you some things. Is very strong. 5.5 is very strong. People fall over, buildings crack. Then as you get higher, obviously the higher the number, yeah, anything near 8 or 7 can be disastrous. So then, and the Mercalli cells use Roman numerals right here. So intensity is subjective usually because of the kind of damage done and people's reactions. And obviously if the earthquake is near a large city, it causes more damage than a remote area too. So really subjective. So what are seismic waves? This is earthquake waves, by the way. Earthquakes result in sudden release of energy, causing seismic waves that make the ground shake. And there's two types of seismic waves: body waves, which go below into the earth, and surface waves, which are more up in the crust. As you can see, the focus, this is where the two plates are, I guess, like frictioning each other or passing or rubbing against each other, and the focus is right here, and the energy is released into body waves, and the epicenter is right on top. Okay, and what are body waves? P and S. So body waves, the P is primary waves. They move the fastest. They travel through solid, liquid, or gases, and they're called compressible waves because they compress, the material moves in the same direction as the wave movement. So for example, the wave is moving this way and compresses, so it's like shrinking, smushing together. Think of like an inchworm, I guess. Smushing together here, compressing, expanding, or like an accordion, compressing, expanding, expanding. So they're moving the same direction. Then S waves are secondary waves. They're slower than P waves, and they only travel through solid because they need to be kind of together to make this S. And it's called shearing waves, and they move material perpendicular to the wave movement. So it's generally going this way, but then when it moves, it's going perpendicular. It's going right to left, even though it's going forward. And then surface waves, there's R and there's L. And then you see the love waves are going that way in and out, and this is more going wave motion. So surface waves travel below and along the ground, slower than body waves. They either roll up and down or side to side, and they do damage because they're on the surface to buildings and structures. So what are seismometers? Seismometers measure the body and surface waves of an earthquake. And also I should add, of all types of earthquakes. So right here, if you look, there's different ones. This one measures more the movement of the earth going up and down, vertical movement, and this is measuring more horizontal movement. And this is usually a very heavy pendulum. And then there are many seismometers or seismographic locations around the world that measure seismic waves. And if you see all the red dots, this is where all the seismic stations are. And as you can see, there's a lot more concentrated on land than in the ocean. And this is some of the readings you'll see. As you can see, it's moving up and down and how fast the frequencies are. How is the earthquake's epicenter located? So how do you know where the earthquake started? So seismic wave behavior. P waves arrive first, then S, then your surface waves L and R. Average speeds for all these waves are already known and calculated. So after an earthquake occurs, the difference in arrival times at the seismograph station can be used to calculate the distance from the seismograph to the epicenter. So for example, if it started somewhere in San Diego and you have a seismograph over here in Temecula or Murrieta, and you can see how fast it got there, you can go backwards and figure out exactly where it started. And so background noise here, it's kind of moving, and then you'll see arrival of a P wave. Then later an S wave, because this is the fastest, and then your surface waves, your L and your R. So how is the Earth's interior discovered? So how do we know there's a crust, a mantle, and an inner core? And yes, we could have drilling, but we can only drill so far. I mean, we looked at some of the diameter of the Earth. They are thousands of kilometers deep. So it's actually from seismographic waves. The P and S waves, they actually, when they're traveling, they refract at the mantle. This is where the mantle and core boundaries are. And they create shadow zones. This is where no or weak waves are detected right here, where it's gray. It's not detected here. So if we have a seismometer in any of these locations on the Earth, we're not getting any readings, or very weak readings. Then the composition and layers of Earth's interior was discovered through the P and S wave readings. So for example, once again, this is the epicenter. It's going out. It's going to start refracting. So we're going to get some waves if we're at the location here in a seismic station. But if we're here, we're getting very weak or none. Then we only get the P waves because they actually go through the core. Well, these do not. S do not. And we'll talk more about that in the next slide. So what is the structure of Earth's interior? So what did we discover from the seismographic data? The crust is a very thin layer of solid rock. Beneath that is the mantle. And the mantle is semi-liquid layer. It's basically softened molten rock because of the heat. It's melting partly, and it moves in convection currents. That's what causes the plates to move and make mountains and volcanoes and earthquakes. Then inside is the core. The core is divided by the outer core, which is liquid. And this liquid is not as viscous, doesn't move as much as the mantle. It's just thick liquid. And it's mostly iron and sulfur. And then the inner core is solid iron and lots of pressure, and it's very dense in the middle. So if you look at the S and P waves going through, S waves don't even penetrate the core because it stops that liquid and doesn't even get to another solid. Then P waves slow down when it passes through the core. So you'll see some weak waves refracted, but the S is completely refracted out. More practice when we go over the notes.